Kindly open the previous model, where 4 numbers of axes, with 5 meters spacing each were created. Or generate them using the orthogonal axis generator. We will now go through the various selection method. All axes and members created will be listed in the respective folders. If you hover the mouse cursor over an entity, a tooltip will automatically appear showing the key properties. Left-click on the entity on the plan view to select the entity. Selected entities are also highlighted in the structure tree. To multiple select or deselect entities, hold down Ctrl key while you pick them one by one. You can also select entities directly from the structure tree. Pressing Escape key will deselect all entities. You can drag with the mouse to access further selection options. Left-click and drag from left to right to create a rectangular box. When you release the mouse button, all entities completely contained within the box will be selected. Left-click and drag from right to left, and all the entities that cross its boundaries will be selected. Click on Selection Filter. This function allows options to select only certain elements that are ticked. For example, if you only want to select axis, click Select/Deselect All. Check axis only. Let us not change anything. Click twice to select all. Then click on the selection filter icon again to close the dialog. If you right-click on a single selected entity, you will see a pop-out context menu, which allows you to edit and perform other tasks related to that entity. Example properties, delete, etc. If you select multiple entities, such as all the axes and right-click, you can access the member table. In this case, by selecting the axes table, you can edit the axis labels easily in a group in a table format rather than individually in the axis property. Close axis table without changing anything. The column can be created using the column icon. If you click on the column tool, the column properties will appear. B1 is the width and B2 is the height of the column. To insert a column, there must intersection of two axes that will become the joint of the insertion. This is defined as the column insertion point. The exact position of column also be moved by inputting an horizontal eccentricity, E1, and vertical eccentricity, E2. This eccentricity is defined with respect to the centroid of the column area, as shown in the red dot here. By default, when you insert a column, E1 and E2 is 0, which means the insertion point coincides exactly with the centroid of the column. A positive E1 offset the column to the right, vice versa. A positive E2 offsets the column to the top, vice versa. This insertion point must be within or at the perimeter of the column. This means the E1 must be equal to or less than the B1. Similarly, E2 must be equal to or less than B2. Otherwise, the column can't be inserted and you will be prompted so. Let us begin the modeling of columns. Before proceeding, it is important to know that whenever a project is started, default Story 1 and Story 0 will be created. Story 1 is the ground floor and Story 0 is the foundation level. A default plan view will be shown. Currently, it is showing Story 1. The view is a top-down view. To switch between story, double-click on the story label in the structure tree. Double-click on Story 0. Notice that the column and wall tool will be deactivated. This is because you cannot insert vertical elements in Story 0, only Story 1 and above. Double-click on Story 1 to change the view back to Story 1. It is important to note that axes or grids are always shared between stories. Hence, it is not necessary to recreate the same axes for different stories. We will now create some concrete columns. Go to the Modeling tab and move your mouse cursor to the RC Column tool. Notice the tooltip will appear with detailed information on how to use this function. In addition, there are short video demonstrations that you can watch. Click on the RC Column tool. The column property dialog will appear. Let us dock this dialog to a convenient position, just to the right of the structure tree. In the column properties, let us use the default size of B1, width equals 500 mm and B2, height equals 250 mm. E1 equals 0 and E2 equals 0 means the insertion point of the column, which is defined by the intersection of two axes, will coincide exactly with its centroid. You can also use the insertion options to quickly define the position of the column. For example, the first option here will insert the column with the upper left corner aligned with the intersection of axes. Notice after selecting this option, E1 and E2 is automatically calculated. Let us revert back to E1 and E2 to 0 values, either by using the appropriate insertion option or by manually typing it. Click on the intersection of axis A and 1 and the column will be created. You can insert multiple columns by click and drag a box around intersection of axes. In this case, 2 columns will be created. Now, create 6 more columns at these locations. Check the structure tree, that total of 9 columns are created. To expose more options of concrete column, click on the Section Manager icon. In the Section Manager dialog, under Concrete Database, you can choose other shapes of concrete such as circular, cross, T, etc. For any other shapes you can use the Polyline Column Editor function. In the General tab, the section name and material color can be changed. These will be used when you use the visual interrogation to color code column of different sizes with different color for visual checking. You can change the section sizes and dimensions in the table. Under Section Angle, you can rotate the column orientation. You can also mirror about X or Y axis. Under Materials, the concrete grade is set to default, which means it will be controlled by the master material settings. We suggest you always use default and not change this unless this particular column has a concrete grade that is unique, that is different from the rest of the columns in the same story. Go to the Properties tab. The selected section properties are all automatically calculated. If you wish, the key section properties can be adjusted by using the factors input box. 1 means 100%. 0.5 means 50%. Alternatively, you can check Edit manually, then all the section properties fields are opened up for manual input. Please choose the circular column and go to General tab. The default diameter is 400 mm. We will use this. Click OK to confirm. Now, insert this circular column at the intersection of axes B and 4. Check the structure tree that a total of 10 columns are listed. Close the column properties as we have modeled all the columns. We will now create a 3D view. Right-click on Views in the structure tree. Select 3D Physical Model. A 3D view will be created and made active. To zoom in and out, simply scroll the mouse view. To rotate, right-click and drag. To pan, hold down the mouse wheel and drag. To arrange the views, go to Views tab. You can tile horizontal or you can tile vertical. Smart Tiling automatically aligns and visualize all views at once. Reset realigns view to original default. The View tab also contains the same functions to create plan view and 3D physical model view. You can create as many views as you like. To close a view, click on the close icon. Alternatively, select the view in the structure tree, right-click, then choose Close View. The 3D rebar model shows the reinforcement in 3D view. This is only meaningful after we design the members, so the reinforcement bars can be shown in 3D view. The analytical model view can only be accessed after the analysis is done. The same view options can be exposed by right-clicking on the view labels. You can also undock the view by a left-click drag. Once undocked, you can left-click and drag to place it anywhere. If you are using multiple monitors, you can even place it on another screen. For now, click Reset and then tile the two views vertically. To make a view active, simple left-click anywhere in the view. The active view label will be highlighted in blue, while the inactive view will be in gray. Let us now explore some handy functions that affects the view. Firstly, refresh display. If you find anything is out of place, click on Refresh to regenerate the active view. The rotation center function is only applicable to the 3D view. Activate the 3D view by left-clicking anywhere in the view. Then maximize it by click on Reset. Now click on Rotation Center. There are two toggles, first is Center. This means that if you right-click and drag, the rotation will be with respect to default rotation center. If untoggled, it will be Cursor. This means the model will rotate about the point where the cursor is placed. Click Tile vertically. The display axis indicator is only applicable to the plan view. Activate the plan view by clicking anywhere in the plan view. When activated or toggled, if you zoom in such that the axis label balloon is out of the boundary of the view, the axis label will still be shown. Zoom window. Click and drag a box to zoom in. Zoom previous goes to the previous zoom state. Zoom extent. If no object is selected, the zoom extent will zoom the extent of all elements. If a single element is selected, zoom extent will zoom to the selected element. This function works for both 2D and 3D views, depending on which view is active. Activate the 3D view. Select any member and click Zoom Extent, and it will zoom to that selected element. We will now go into details of columns. Before we proceed, save the model. When the Save button is deactivated, it means the model has been saved. Deselect all columns in the 2D and 3D view and zoom extent. Select column 1C1 at the intersection of axes A and 1. Right-click, Properties. The properties of this column will be exposed. Note that if you change any of the fields, you must click Update for the change to take effect. It is not automatic. LEN, or length equals 1, means this column spans one story. From top of story 1 to story 0, foundation level. Column anchor. You can apply an anchor to the edge or a corner of the column, so the anchored edge or corner does not move when the column size is changed. For example, choose the top left anchor. Press Update and the anchor sign will appear at that corner. Now change the size of column to 600 by 300 and update. Notice that anchored corner does not move. To remove the anchor, simply choose the middle option, followed by Update. The top and bottom insertion axis is shown here for information. End condition icon. By default, all columns inserted will have both ends fixed. You can click consecutively to hinge the top, bottom or both the ends of the column. Angle. The column can be rotated. All angles are measure horizontal anti-clockwise. Try to key in a value and click Update. Then change it back to 0. Update. The direction icon here controls the orientation of column with respect to the insertion axis, in the case where insertion axis is not orthogonal. It is an alternative to using the angle input above. Click on the Drop tab. In flat slab type floor systems, a drop panel or column head can be inserted on top of the columns in order to increase punching shear resistance. To place a drop panel, check Insert Column Drop Panel. Dimensions, B1 and B2, and eccentricities, E1 and E2, of the drop panel are identical with the column. Depth of the drop panel can be defined by using H-drop field. This is measured from the top of the slab. Hence, this depth should be more than the slab depth. Go to the 3D tab. The plane fields will be populated if a plane element is created and used to adjust the column height. Delta Z controls top and bottom node position of the column. By default, delta Z equals 0 means that top and bottom column nodes coincides with the top and bottom of the story. This means that by default, the height of the column is exactly the same as the height of the story in which it is created. As shown in this diagram, if you key in positive value for bottom of the column and update, it means you are raising the bottom of the column, that is, column is shortened. Be very careful when using delta Z adjustment. For example, if you mistakenly input a wrong negative delta Z top, the top of the column will be lowered. Hence, the beams modeled at the floor level will no longer be supported by this column. Support types. Generally, this should always be set to default unless a user-defined special support type is created. When a user-defined support is created, it will be added to the drop-down list and you can select it. By default, when modeling column or walls in Story 1, there is no need to create any user-defined support The program will automatically provide a support during the analysis. Transfer member. Check this option if this column is discontinuous, that is, it does not continue down the lower floors. A transfer discontinuous column can either be supported by a beam or slab. By checking this option, automatic rigid links will be created to support this column if the insertion point of this column does not coincide with the insertion axis of the transfer beam below. Further, you will not be prompted with an unsupported column warning message during analysis for such cases. Close the column properties. Since we have made changes to this column, let us delete it. Press Delete key or right-click, choose Delete. To easily recreate a column with the same parameters, we can choose any adjacent column, right-click Properties. Then click on the intersection of axes to recreate the column. Relabel this column 1C1, Update. This method is equivalent to a copy command. Close the properties. Save the model.